We are going to look at graphs of exponential functions today. We'll start with the warm-up problem. Let's say you buy a car for $30,000. Kelly Blue Book estimates that the car you bought depreciates in value, and depreciate means it decreases in value, or goes down, 15% a year. So I'm going to underline the important information. Part A, write the equation that represents the situation. So we're going to take a look at the starting value. Here it's 30,000. And if it's going down 15% a year, you want to think, what percent is it still worth? So we're going to do it 100%, but it's going down 15% a year, which is 0.15. And then we're going to have x here be the number of years. Another way to write this is y equals 30,000 times 0.85 to the x. Excuse me, what that means is every year the car is worth 85% of the value of its value from the year before. This would be decay. Again, it's going down in value. You can tell because it's less than 100% of its value each year. Let's look at the graphs. I graphed this on Desmos. I just typed in the equation. It says, using the graph below, estimate how long it will take to reach half its value. Well, half its value, if it starts at 30,000, would be 15,000. So half its value we're looking for when is at $15,000. And if I look at the graph right here, let's make this a little bit smaller. 15,000, I'm going to draw a line down. I have to draw it. Here we go. All right, so let's do this in purple. How about? All right, so here's 10,000, 12, 14, 16, 18. So this is going up by twos. So this is 12, 14, here's 15,000. I'll draw a line across. It should be more in the middle here. And we're going to look for that point of intersection. And if I draw a line down, we can estimate the number of years. And this is going up by 2, 4, 6, 8, 10. So this is 2, 4. It's a little after 4 years. So again, here's 4 years. And we can see it's slightly after 4 years, the car is worth half of its value. And then it goes way down after that. We can see at 30 years it's worth almost nothing. All right, let's take a look at the rabbit population in Australia. You can see it's exponential. It increases quite quickly. According to the graph, how many months does it take for the rabbit population, let's just say, to double from 1 million to 2 million rabbits? All right, so here's the rabbit population in millions. Here's 1 million. Here's 2 million. So let's go across and see how long did it take to reach 1 million. So you go across. Oops, it's not very straight. And you're going to go down. So if you had to estimate that, this is a 48, this is 60. What's the middle of 48 and 60? Let's figure that out. So this is about 54 years right here. So we can say about 57 years, I would estimate. So this is 57 years for the population to reach 1 million. Let's look at 2 million. So 2 million, let's do it black. We're going to go across. We're going to go down. So that's about 60 years, we'll say. So it takes only 3 years for the population to double from 1 million to 2 million rabbits. The last thing we're going to look at today, so we look at reading graphs, is graphing. So let's say we have this function y equals 2 to the x. If I asked you what the starting value for this would be, it's actually a 1. So notice 2 has the exponent. So that's your growth rate. So really there's an invisible 1 here, 1 times 2 to the x. So the starting value is 1. What is the growth or decay rate? This is a growth rate. It's 2. And the growth or decay rate has the exponent, it's the base of the exponent. Let's fill out the following graph and table, and we could just plug in. So when x is -1, here's what you're going to type in. Y equals 2 to the -1 power. Remember from our exponents chapter, that means the same as 1 over 2. You flip it. So this is 0.5. Let's do the next one. Y equals 2 to the 0 power. Anything to the 0 power is 1. Let's do the next one. Y equals 2 to the first power. That's 2. Let's do the next one, y equals 2 squared. That's 4. And the last one is y equals 2 to the third, which means 2 times 2 times 2, which is 8. So let's graph this. At -1, we're at 0.5. At 0, we're at 1. At 1, we're at 2. At 2, we're at 4. And at 3, we're all the way up at 8. So we can see this is increasing exponentially. And so we filled in our table here using our equation. So in today's assignment, you're going to practice reading graphs. You'll have some review problems, and you're actually going to be graphing some exponential functions as well.